We remember the great news about the success of the Double Asteroid Redirection Test, or DART, which sent a small spacecraft crashing into Dimorphos, a small asteroid that is orbiting around a larger asteroid called Didymos. The test demonstrated that we can use this method to deviate asteroids or other big rocks that are in a collision course towards our beautiful planet. The DART impact happened on September 26, 2022, and since then, scientists have been following the asteroid pair to see what else we can learn from this human-made event. And that is why on December 2022, a group of astronomers using the Wide-Field Camera 3 on board of the Hubble Space Telescope took a series of images of Dimorphos, and with those images, they identified 37 sources or boulders in the region around this asteroid. In the Hubble image, the Didymos Dimorphos system looks like a star because what we are seeing are the diffraction spikes that are produced by objects that are too bright for the camera and the filters that we are using to take the image. Of course, those are not real, but the most prominent feature that we see in this image that looks like the tail of a comet is actually the debris tail that the impact left. While the small and almost visible point sources in this image are actually the boulders that this team identified, and those extend to about 10,000 kilometers from the system. The team calculates that the total ejected mass that is contained in all these boulders is just about 0.1% of the total mass of Dimorphos, but it is actually 10,000 times more massive than the DART impactor. The team was able to also derive the size of the largest boulders, and they determined that those have diameters between 4 and 7 meters, and that those are moving at a projected speeds of about 0.1 to 0.7 meters per second. This means that some boulders will be able to escape the system, while others will be trapped due to the gravitational pull of the Didymos Dimorphos system. For boulders to be able to escape, those actually need to be moving at speeds that are faster than 0.24 meters per second. However, those boulders that are moving slower and they are going to be trapped into the system, they are going to be trapped only for a small period of time, because eventually some of them will be colliding with other of the objects in this system, while others will end up being accelerated by near-miss encounters with other of these objects and will be able to escape. But where do the boulders that they observe come from? When studying the penultimate image that was recorded from the DART impactor, the team found that the crash site has boulders of all sizes. One of them, that is called Atavake, is a large boulder with a diameter of about 5 meters, which is comparable to the size of the observer boulders. However, they also explored the possibility that the boulders are created as part of the impact itself, but at the end, the conclusion was that the numbers, sizes, and shape of the boulders that they see in the image of HST are more consistent with pre-existing objects that were knocked off from Dimorphos by the DART impact.